Hello, and welcome to my first of 3 videos on crazy formulas. So let's jump right into example number 1. Here we have, after heating up in a teapot, a cup of hot water is poured at a temperature of 205 degrees. So I'm just going to underline that number because I'm sure we're going to use that as part of this problem. Next we have that the cup sits to cool in a room at a temperature of 67 degrees. I'll underline that number as well, because I'm sure we're going to use that as part of our problem. Then we have Newton's law of cooling explains that the temperature of the cup of water will decrease proportionally to the difference between the temperature of the water and the temperature of the room. And that's a lot of mumbo jumbo there, but basically they say that all that is given by this formula below, and this is basically what the formula we're going to use to help answer this question. Beneath that, we see 4 bullet points, each of which describes what each part of this formula represents. So T of T is the temperature of our object at a time T hours has elapsed. T of A is the ambient temperature, which is another word for saying the temperature of the surroundings or the room temperature. And this is assumed to be constant and not impacted by the cooling process. T sub 0 is the initial temperature of the object, and K is the decay constant. So the first part of this problem, part A, says that if the value of the decay constant is this 0.084, write a function, which basically means an equation, in terms of time t. So what we should identify, perhaps, is what each of these parts of this formula represents to put together our equation. So again, T of T is the temperature after T hours. Since our equation here is going to be in terms of T, we'll just start off writing T of T because that'll be a part of our final answer. T of A, again, is the surrounding temperature or the room temperature. If you recall, there were 2 temperatures given at the get-go of this problem. The second one is our room temperature. So I'll write that T sub A is equal to 67. T sub 0 is the initial temperature of our object. That is our 205 degrees because that was the temperature of the cup of hot water when it was originally poured. So I'll write that T sub 0 is 205. And K is our decay constant, and that was given right over here in part A. So now we can write all these parts into our equation to get our answer. Again, T sub A is our 67. Then we have plus parentheses, T sub 0 minus T sub A. T sub 0 is 205 minus T sub A, which is 67. And then after this we have E. Remember, E is that special number. It's like pi, and so we'll just leave that as a part of our answer. And then we have minus K, which is our decay constant, which we were told is 0.084. And then we have times T, and our answer is supposed to have that little t as a part of our final answer. So this is our equation and our answer for part A. Now for part B, basically we're asked to determine what the Fahrenheit temperature of the cup of water would be to the nearest degree after 4.5 hours. So we basically can use our answer from part A, and now because T represents our time, we can plug 4.5 in for that little t to get our answer. So we'll just plug 4.5 in for t, and that'll equal our 67 plus parentheses 205 minus 67 parentheses e raised to the negative 0.084 times our t of 4.5. And that's the setup to our answer. And as with other problems, since we have basically all numbers written out here, I would just plug all this directly into your calculator exactly the way that you see it here, and you should get an answer rounded to the nearest integer of 162 degrees. So I hope this video was helpful to helping you understand how to answer question number 1. I'll see you next in video number 2. Take care.